We're going to continue with our calculus review. This is going to be 4-2, and we're going to be solving trig equations. The way that I want you guys to think about this is almost like an introduction. We're not going to do anything complicated just yet. Now, when solving trig equations, there's going to be certain strategies that will help us. For example, with sine and cosine, if it equals some number, that number should be between -1 and +1, or it's not going to work. And we're going to solve values that are going to be on this interval between 0 and 2 pi. And we're going to go through this process of trying to find every single possible solution there. And we just need to remember that the natural period is 2 pi. Basically, if it's secant or cosecant, we need to convert it into cosine or sine respectively because it makes it easier. With tangent, same idea, except that the period is now going to be pi. And to solve for cotangent, we want to convert it into tangent because that makes that process so much easier. Now, when we actually do solve it, what we're doing is we're looking at the unit circle, and let's just say hypothetically, I say this is like 30 degrees. Well, if I rotate it around 30 degrees, that becomes 390 degrees. If I rotate it again and again and again, I'm going to get these infinite rotations. Now, having said that, the sine of 30 degrees is going to be 1/2. Well, the sine of also that 390 and rotating it again and rotating it again and rotating it again, they're all going to be the same value, which is going to be 1/2. And so we're going to algebraically express this infinite number of rotations that could give me that value there. So just know that in our final answer, we're going to have to express that. So the question is asking us here, it says solve the following equations, list all possible solutions and all the solutions on the interval between 0 and 2 pi. So the first thing, because this is cosecant, I can convert this into sine. So this is going to be the sine of 1/3 x minus pi. And this is going to equal 1 over radical 2. Now, if I rationalize that, that becomes rad 2 over 2. To get rid of the sine, because since we're solving for the variable x here, to get rid of the sine, I do want to take sine inverse to both sides. And if I take sine inverse to both sides, I'm going to get 1/3 x minus pi equals the sine inverse of radical 2 over 2. And so the question is, in terms of radians, what angle gives me radical 2 over 2, and so on the unit circle that's going to be pi fourths and 3 pi fourths. So I can say that this is going to be 1/3 x minus pi equals, now I do have that pi fourths and I do have that 3 pi fourths. But I have every single iteration. Right, we said that we're taking this, if it's at that pi fourths, I'm rotating, and I could also rotate in a negative direction. So how do I represent that? Well, we say, well, how much is it rotating? It's going to be 2 pi, and I'm going to say some integer k. And so we say where k is an integer. Now, I'm not done, right? X isn't by itself, so I still have to add pi to everything. So I'm going to add pi to everything. And so adding pi, I'm now going to get 1/3 x equals 5 pi fourths plus 2 pi k. And pi plus 3 pi fourths is going to give me 7 pi fourths plus 2 pi k. And then to get that 1/3 by itself, I need to multiply everything by 3. And so I'm going to get x equals 15 pi fourths plus 2 pi k. And, sorry, this would be 6 pi k. And this is going to be 21 pi fourths plus 6 pi k. So I distributed that 3 with everything. So now this right here, this answer, that's going to be listing all possible solutions. That's every single possible solution that could ever exist. Those are the algebraic way of representing that infinite number of values. Now I have to find all the solutions that are on the interval between 0 and 2 pi. Now the way that we imagine this, if this is 0 and this is 2 pi, I want to find any value that's in between these numbers. We don't want that. We don't want values over there. Now to find those actual values, you have to plug in values for k. So if I say k equals 0, well, if I plug in k equals 0, I'm going to get 15 pi force plus 6 pi times 0, and 21 pi force plus 6 pi times 0. Well, this is just 15 pi force, and this is 21 pi force. That is messy. Now, if I enter that into my calculator or try and simplify that, that is not going to be between 0 and 2 pi. And so because it's not 0 and 2 pi, that doesn't work. So that's too high. It's actually on this side of the interval. So because it's on that side of the interval, maybe I should try something smaller. I should try k equals -1. So if I plug k equals -1, I'm going to get 15 pi force plus 6 pi times -1, and 21 pi force plus 6 pi times -1. Now having do that, common denominator, 4 over 4, 4 over 4. Now simplifying that, this gives me -24 pi over 4, so that gives me -9 pi force. And then for this one, -24, that's going to give me -3 pi over 4. Now both of those are negative, so that's going to actually be on this side of the interval, and so those don't work either. And so believe it or not, there's no values that are between 0 and 2 pi. And so that's going to be my answer for that one. So as a recap, we're just solving. So we literally employing everything that we know in terms of manipulating a trig equation. And so that's all I did here, is just employ all the stuff that I know. We talked about inverses, and the only new notation is that I'm including all possible solutions, and you're going to say plus 2 pi k to do that because the period is 2 pi. Now it's going to be a little slightly different when we get to tangent. Then once you've established all possible solutions, then you need to find the values on the interval, and so you have to actually start plugging in values for k to explicitly find those values going to be on the interval. And so showing the work here, those values were too large. I went a little bit smaller, so k equals -1. Those values were too small, so there are no values between 0 and 2 pi. For this next one, so this is where if I take the sine inverse to both sides here, I'm going to get 2x equals the sine inverse of 0.87. So this is where we're actually going to have to enter this into our calculator. Now if you're wondering, why do I have to enter this in your calculator? And that's because there's no value of 0.87 on our unit circle. So doing the sine inverse of 0.87 in my calculator, it's going to give me 60.46 degrees. Now we have to visualize this just a little bit. I know that this rotation here, this is 60.46 degrees. This is positive, so sine is positive in this quadrant and in this quadrant. Now trying to solve for the value, I know that the reference angle is going to be the same, so this is also going to be 60.46 degrees. And so the full rotation here, from here all the way to here, to find that I'm going to have to do 180 degrees minus 60.46 degrees. And so entering that into our calculator, I'm going to get 119.54 degrees. And so the two values that I'm actually going to get for that are going to be 119.54 and 60.46 degrees. Now because the interval does say between 0 and 360, that means that when I write the all possible solutions, I'm going to say the 60.46 degrees plus 360k and the 119.54 degrees plus 360 degrees k. Now I can continue getting x by itself. So dividing everything by 2. So I'm going to get x equals, this is going to be 30.23 plus 180 degrees k. And then entering the 119.54 into your calculator. Divide that by 2, you're going to get 59.77 degrees plus 180 degrees k. So this right here, this is listing all possible solutions. And so now finding all the values in the interval, you need to start plugging in values for k. So plugging in like k equals 0, you're going to get 30.23 degrees plus 0 and 59.77 degrees plus 0. So far, I'm going to get 30.23 degrees and 59.77 degrees. Now to find the other values, I have to plug in k equals 1. If I plug in k equals 1, I'm going to get 30.23 plus, now this is 180 times 1, and 59.77 plus 180 times 1. So plugging that in there, I'm going to get 210 degrees, or 210.23, and then for the other one, you're going to get 239.77 degrees. And so my other values are going to be 210.23 degrees and 239.77 degrees. Now if I try k equals 2, notice that I'm going to take the 30.23 degrees and I'm going to add 360 to it. Well, that's going to be outside between 0 and 360, so that's too large. I don't need a plug anymore. And so those are going to be my answers there. For cotangent, this is the cotangent of 3x equals 0. Well, I said we should convert it into tangent. So this is going to become the tangent of 3x, and this is going to equal 1 over 0. Because I have to flip it, 0 over 1, that gets flipped to 1 over 0. So where is my tangent going to be undefined? And so that's actually my intervals at pi halves, so it's going to be between pi halves and 3 pi halves. So now having said that, if I do all possible solutions here, tangent, if I take the tangent inverse to both sides, so I'm going to get the tangent inverse. That's going to be pi halves plus pi n because of the period, right? It's pi instead of 2 pi. And the other one's going to be 3 pi halves plus pi n. Now the issue here is this is actually being redundant. And so if I start plugging in values for k, I wrote n. You can write k if you want, or n, doesn't matter as long as you're consistent. But if I plug in values for k, like k equals 0, I'm going to get pi halves and 3 pi halves. If I write in values for, say, k equals 1, I'm going to get 3 pi halves and 5 pi halves. But now notice here, the issue with that is, look, I'm starting to repeat myself. And so you could actually combine these together. All you have to do is just take the smallest one, so pi halves, and you just write plus pi. Okay. So now we're not repeating ourselves. Everything's okay. And now we can continue on solving. So dividing everything by 3, I'm going to get x equals pi 6 plus pi k over 3. And remember, where k is an integer. And so now solving for this, this right here, this is all possible solutions. But now plugging in values for k, so like k equals 0, that's just going to give me pi 6. If I get k equals 1, that's going to give me pi 6 plus pi thirds. And so that's going to give me a 2 over 2. And so that's going to give me 2 pi 6, so that's going to be pi halves, or 3 pi 6. And then if I plug in k equals 2, that's going to give me pi 6 plus pi times 2 over 3. So 2 over 2 again, that's 4 plus 1, that's 5, so that's 5 pi 6. K equals 3, that's going to give me 7 pi 6. If I plug in k equals 4, that's going to give me 3 pi halves. And if I plug in k equals 5, that's going to give me 11 pi halves, or 11 pi 6. So those are all my values for x right here. And you can write them out saying x equals this one, and 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 you'll have your answers there. Now for this last one, I know this one seems a little confusing, but this is actually a sum and difference identity. This is actually the sign of alpha plus beta. And so if we recognize that that's my alpha and that's my beta, I can now say that this turns into the sine of x plus x over 2. And so this will become the sine of 3 over 2x equals 1. And then take the sine inverse to both sides and solve from there. Now just remember, when I do have that 3/2 x, the sine inverse of 1, that's going to be pi halves plus 2 pi k. You do have to multiply everything by 2 and divide by 3. So multiply everything by 2 and dividing by 3, I get x equals 2/3 times that pi halves plus the 2/3 times the 2 pi k. So just remember, when you go through simplifying that, x would equal pi thirds plus 4 pi k thirds. And then where k is an integer, and then you have to start plugging in values for k equals 0, for 1, 2, etc. So in conclusion, what was reviewed today? Well, we examined how to solve trig equations, and we looked at both basic 6-function trig equations, sine, cosine, tangent, etc., and various examples what I need to do with that. But we also looked at when it came to identities, and we had an example there where I had to use an identity to turn it into a format in which I could solve it. If you had a reciprocal trig function, what should you do, and what types of identities were used? So I want to hear from you guys. If you have any other questions, please leave them in the comments.